Hello, and welcome to Onward, the Fundrise podcast. I'm Cardiff Garcia of the Economic Innovation Group, and I'm joined as always by Fundrise CEO and legendary surfer of tech waves, Ben Miller. Ben, hello.
Hey, Cardiff, how are you?
Just teasing up the episode there. Why don't you tell everybody what we're about to talk about, because this is one of the most exciting topics that we've covered on Onward, I think, to this point.
Yeah, so our team did a lot of research and analysis for this episode. We went back and looked at top 100 or a couple hundred largest tech companies going back 30, 40 years and looked at revenues and market caps. When we did it, we found some surprising patterns. And then also, as I dug deeper into them, the patterns were so visible that I even wanted to name them. So I took a shot at
Custom named them?
Yeah. Some of them are custom names. Some of them are well-known in the industry.
Are borrowed, let's say. Yeah.
Because some of the patterns are very familiar to insiders. Everybody in tech who's been around knows these patterns. And some of them, I think, are not as well-known. The financial metrics around these, I think, I hadn't seen anybody ever do this kind of research, looking at hundreds of tech companies over decades and decades. I think a few of these things will be really new even to insiders.
Yeah, I want to point a couple of things out to our listeners. One is, you have not shared these findings with me before the chat on purpose. I'm going to be as surprised, shocked, delighted as our listeners are. And hopefully I can also then act as an avatar for our listeners and ask follow-up questions and all that kind of stuff. And also, we want to emphasize before we get started that this podcast is not investment advice. This is for entertainment and informational purposes only. And oh my, is it going to be entertaining. I can't wait. Ben, these patterns that you described and that we're about to introduce, they don't just apply to these hundreds of tech companies that your team studied over the last several decades. They apply to the waves of technological innovation that those tech companies represented. Is that correct?
Right. But before I get into it, let me just say one thing about patterns, is that why do patterns matter? And so VC investors will often describe themselves as pattern matchers, because they often say is that they see more data across more companies. And so they're really good at recognizing patterns. And entrepreneurs is so funny. If you're starting a tech company or in a tech company, you work in tech, these patterns are so consistent, yet it feels like every time they happen, people don't know that and they seem new. I sum it up as like nearly everything's happened before in the past. And so we might as well learn from it. So there's been 5 major waves of technological innovation
in the last few decades, to be clear, not like forever.
Yes, in the sort of what I would call modern technology era. And that would be like with the launch of that first computer.
Okay.
And those 5 sort of tidal waves were mainframe, personal computer, internet, mobile, cloud computing, and now AI.
So mainframe is the first one, the PC. So it's PC, internet, mobile, cloud, AI. Got it.
Yeah. The first was mainframe, and there's a whole history there. And the personal computer was the first sort of disrupting wave. The first computers were mainframes.
Yeah. And so you've discovered 5 patterns that seem to apply consistently to all 5 of these waves, correct?
Yeah. First, people should know that the wave pattern is a pattern, and that catching the wave, recognizing the wave, helping create the wave is the most important way you make money in tech. I didn't want to skip that part, which is that there are waves in technology. There are big waves, which is these big breakthroughs. These waves go through these sort of like life cycle, which is like a breakthrough, adoption, maturity, and then old age or senescence. So before I get into all these patterns, the first pattern is there's waves. And if you don't know, that's a pretty important one. But okay, let me give you the other ones. So the other ones, some of these I had to name myself. So 1 are waves. 2, I'm calling the bridging pattern.
Okay.
3, democratization. 4, centralize-decentralize. And 5, the 3x multiple.
Some of those names sound more exciting than others, right? Even the idea that VCs describe themselves as pattern matchers just doesn't sound quite as sexy as saying I invest in technology, right? Pattern matching sounds like something you do to choose your drapes. But let me just go back through each of these 5. So waves, the first consistent pattern is that it is an actual wave. Second is bridging. Third is democratization. Fourth is centralization, decentralization. And then fifth is the 3x multiple, right?
Right.
Okay. Do we want to define each of these and then dive in, or should we just start going with the first one?
I'll do a quick summary of each, and then we can dive into them because they're each pretty deep. And the one that I feel like is the one I named, I'm calling it the bridging pattern, is the most important pattern in tech and is actually the primary job of the tech industry. You would think it would have a name, but it's basically to take the innovation from the hardware to the human. So just to try to give an example of that, right? The mobile phone and in the chips inside are the hardware. An application might be the app store, right? It's where all apps have this sort of shared infrastructure. And then an app might be Airbnb. And so those are three parts of the stack. And each part of the stack's getting closer and closer to the customer. And that's the bridging pattern, because getting this innovation, this sort of unlock to the customer, is how the technology industry monetizes. And then the third pattern, democratization pattern, is then the technology ends up giving more people more power, more computing power, more ways to solve problems in more places. If you think about it, like the iPhone has 100,000 times more computing power than the computer that landed the space shuttle on the moon.
Yeah. And another way of saying that is that all this computing power has also just become a lot more affordable.
Right. So that's democratization, and one that's near and dear to my heart.
Indeed, the mission of Fundrise is exactly that, to democratize investing in private assets.
Yeah. And so then the fourth pattern, academics would call it centralized, decentralized. The software industry calls it bundle, unbundle. And the hardware actually used to call it construct, deconstruct. But basically, there's consistent patterns of how technology will end up causing power to centralize or power to decentralize.
Yeah, Ben, can you say a little bit more about that? Can you untangle what you said there about bundling and unbundling and how that connects to this concept, this pattern of centralization, decentralization?
Yes, I'd love to. And we can go deeper into it when we get to the next part.
Save it for later then.
Yes.
And the last one, the last pattern is the 3x multiple, which sounds tasty, I got to say. This is the one everyone's going to like.
This is the financial pattern. And this is what we found in our research work, financial patterns. And so the three were a consistent market value. And what we found was each wave was about 3 times bigger than the last wave. So the internet was 3 times bigger than the PC from a market cap or market valuation of all the companies. Mobile was 3 times bigger than the internet. So each wave ends up being 3 times bigger. And that was interesting because we were trying to estimate the size of the AI and how big AI's market cap could be. And we actually ended up at a number of 15 trillion based on the consistent patterons. And there were also
That's
patterns.
What it is right now, or is that a projection based on the 3x concept?
Projection. AI is not worth 15 trillion today.
I was going to say, okay.
At maturity. So what's the value of a wave at maturity? Each time it's grown about 3x. And there were consistent patterns around the market split and market value split and market share and winners and losers. So I'll get into that when we get to it. But they were really consistent patterns in the 3x multiple. I almost called it the constructive wave pattern for those who are real nerds.
I like 3x. It sounds futuristic because it is the financial pattern of these 5. I quite like that name. But yeah, that's great. Okay, so we've got these 5 patterns, which again are waves, the bridging pattern, democratization, centralization/decentralization, and then the 3x multiple. Shall we start going deep on each of these one by one then? And we'll talk about some of the examples that we have to illustrate how each of these particular patterns ends up manifesting?
Yeah, because they'll make more sense as we get into the details and people who have more background. So I thought we could start with the waves, the 5 waves, or I guess it's really 6 if you want to go back to mainframes. But the computer was invented, and the sort of initial wave actually was replacing punch cards with computers. Then the subsequent waves are PC, internet, mobile, cloud, and now AI, arguably. We don't know for sure yet, but it seems very likely at the moment. And so just to try to put some color on that, because I think people may understand better with some examples. So PC, the wave hits and you end up with hardware winners, platform winners, and application winners. Because over time, as the wave matures, you end up with consolidation. So examples in hardware and PC are Intel, IBM, Compaq computers, Dell computers, right? Those are all the hardware winners. And in the platform, the winners end up being Windows. Windows operating system is the software platform that sits on top of the hardware. And then all the applications that people build sit on top of Windows. An application might be Adobe, or it could be Microsoft Office, like Excel and PowerPoint. So you see, if you were going to build an application, you say, okay, I want to build something. I don't want to have to design all the operating systems that need to talk to the hardware. I want to just sit on top of somebody who's done that. And so that's what the platform is. Let me give you another example, which is, I think we talked about, but the mobile hardware is iPhone, Samsung, right? And Qualcomm as their chip makers. And then the platforms, there's only two platforms, Apple App Store and Android. And then all applications sit on top of that, Instagram, Uber, Airbnb. That's actually how, and I could go through every single wave, but that's how every wave is organized. And the innovation starts in the hardware and works its way up to the platform, the application. And actually, if you look at every wave, interestingly, there's a lag between when the hardware innovation is created and when the platform gets created and when the application finally, the thing customers use. So typically the hardware is invented 7 years before the platform. So like the Intel x86 is created and you don't see Windows till 7 years later. So anyway, so there's this very consistent wave. And why that matters so much is that it's very hard to, once a wave is established, to basically create a startup or a competitor. So once the players in the wave have won that wave, you can't really disrupt them and they just have a monopoly type profits. And what we've been seeing in big tech is like the late stages of that. And then people haven't been happy with it, but the next wave creates this massive opportunity for new winners. And that's why waves are so important.
Yeah, the one thing that strikes me about each of these particular waves also is that it's not like each of these waves only ended up having a huge effect on information services or information technology. These are what a lot of economists might refer to as general purpose technologies. Some are more important than others, but each of them also has an effect on how every other part of the economy operates. And it's natural, I think, for that to just take some time for it to have that kind of effect. It has to spread throughout the economy, throughout society, and it has to gain wider acceptance to the point where people realize that it's worth buying, it's worth consuming, it's worth investing in if you're a company. And that doesn't happen overnight.
Yeah, it takes on average over a decade from when the initial innovation is created to actually customers who are non-technical are seeing benefits. So the lag was a lot longer than I thought, but that's why the bridging pattern is so critical, because essentially most people, which is how companies make money by selling to many companies, many people, they are non-technical. And so you have to get the innovation to a point where someone who's non-technical can use it. And that takes a really long time, like
Yeah, it
basically a
does.
decade.
Yeah. And by the way, not every technology that looks like it has the potential to transform society necessarily plays out the way its most optimistic boosters necessarily expect. And here I come back to crypto. Crypto is something that people thought, especially chain technology, might end up like really radically changing the way we do things, the financial sector, even the healthcare sector. And it just hasn't played out that way. Crypto, for the most part, remains a speculative investment asset, but it has not actually radically transformed anything. And so you can understand why it takes some time to adopt all these technologies, because each time a company says, hey, maybe I'll invest in that, there's a chance it won't work out. And so it helps to have a lot of first movers who say, yeah, we'll try it. And then they do a lot of the sort of the beta testing or whatever. And then when it works, then you see a larger number of companies say, yeah, okay, we'll take it on and we'll employ it at our company as well.
Because the gains can be so large. If AI is worth 15 trillion, then it makes sense why all these companies are currently investing tens of billions to try to win it. There is still a possibility that AI ends up not being a wave, or at least not anytime soon. That's not what I personally think. And then the other thing that's actually interesting when you go back and look at the patterns is that the early winners don't always win. And so if you went to each one of these waves and looked at early winners, so I'll go to the internet, right? The early winners were Yahoo and Lycos and AOL. And now Google ended up winning all of those. And the same thing happened with social media, right? Friendster, MySpace were early winners, and Facebook ended up being the dominant platform. So it's likely that a lot of the players that currently seem like the absolute winners, AOL at one point was worth $100 billion. That was, I think, 1999. Yahoo was second most valuable internet company, and neither of those really exist.
Yeah, seriously. One last thing I'll say about this first pattern is that very often what ends up happening is that you do get for a time a financial bubble and everybody worries about it, or they point out how crazy the frenzy is and they say, wow, look at these valuations are crazy and so forth. And that could be true. But a financial bubble also very often enables a lot more capital investment in a new technology than otherwise would have taken place precisely because of all that enthusiasm. And sometimes, as it did in the early 2000s, it does lead to a crash or possibly even an economic recession if it's widespread enough. And then you have a longer period of consolidation around these new technologies. You have people start taking a more judicious approach to employing them. You sometimes get new regulations in the aftermath of the crash and so forth. But the point here is that progress can be uneven sometimes. Maybe we'll get lucky and the next big technological innovation, if it is AI, let's say, will take off and it'll be great for everybody and for the economy and society, even in the absence of a big financial market collapse or a recession or whatever. Maybe not. I have no idea. But the point is that sometimes the progress is very uneven, and it doesn't actually mean that big early frenzy of investment was necessarily a bad thing overall, right? Even though it looks quite bad, and even though a lot of people really do lose their money.
Yeah. In the early phase, there are winners and losers. And if you're going to put your money into it, that's the reality. The winners have extraordinary gains, and the losers usually go to zero, even when the companies seem like the sure things, like an AOL or Yahoo, or if you go back earlier, Netscape was the first sort of like popular browser, and it was worth whatever, a few $1 billion. And Microsoft Explorer ended up taking 99% of the market by like 1999.
Yeah. Remember when I said that this podcast was not investment advice? I'll break that rule just momentarily and say, pick the winners. That's better.
Yeah.
That's better. That's better. That's investment advice.
Yeah.
You can put that on the record.
And then the other point you're making is that there can be massive societal benefits, even from the losers. And so a good example is that as the telecom industry put something like $500 billion into the ground building telecom infrastructure, and then basically the whole industry went bankrupt in the early 2000s.
Yeah, WorldCom collapsed, but left us with all this great infrastructure,
yeah.
communications infrastructure. That's
And
right.
So,
yeah.
And so it's a great example of, you could see hundreds of billions going to AI. It'd be great for society and then not for the investors. And that's actually a pretty typical pattern. And that's okay, as long as you can try to either index the winners or maybe judicious in the beginning. But for venture capitalists, this is the game they play. This is how they make the big bucks. So for them, they're obsessed with these patterns because they're trying to figure out, is this a wave? Who's going to win this wave? And then how do I play it? And if I'm an entrepreneur, which I'm also an entrepreneur by day, that is critical because you have to know what's happening in the wave. And I feel like a lot of times people don't see the broader context. Okay, let me go to my favorite one, which is the bridging pattern, because I feel like that pattern actually explains what's happening during these waves. Why does it take 10 years? Because that seems like an extraordinarily long time. But actually, it can take even longer for the innovation to work its way from the bottom of the stack, from the hardware, up to the customer like my mom.
Your poor mom catching strays on this show, all right, for being tech unsavvy.
Oh,
how rude.
She's definitely gives the Fundrise IR team their share of questions.
That's great.
She always writes in, Ben's mom here. And then she's always like logged out and can't get in.
can't complete the sentence.
So
just catching strays. We apologize, Ben's mom.
But this is like a really interesting one because there's really clear patterns in this bridging dynamic. And that bridging dynamic or that bridging pattern is important because if you're going to try to invest into it or entrepreneur or even work in the tech industry, seeing what's happening, seeing actually what the work is remarkable because I feel like oftentimes if you're a software engineer, you actually don't fully recognize or you're a product manager, what is happening because you're so far in the weeds. The broad pattern is you have to go from highly technical to highly non-technical. And the economic value is created by the user interaction, the user interface that unlocks that simplicity. And so I'll give you a few examples of that over time. The most famous one is the original computers were black and white screen or whatever, green screen with just a DOS command line. You had to only type text and you had to know what kind of commands to type. I remember trying to figure out how to get my games to run and I had no idea what the commands were. That was the original interface. You had to be at least technical enough to understand the command line. Here I am showing my ignorance.
Well, I was going to say showing which is also my age,
Yeah,
right?
yeah.
Like there's a lot of young people who are like, what the hell is this guy
What the hell is
talking
a
about
DOS
right
command
now?
line? Yeah. My Commodore 64.
Oh, yeah.
So what Xerox PARC figured out was that people didn't want to interact that way. They wanted a graphical user interface, pretty pictures. And so they created this GUI, and then Steve Jobs saw it and copied it. And then Microsoft copied Steve Jobs. And so the way we interact with the computer today, which has got the file folder and it's all organized, it's actually a metaphor for an office, right? Because it's got files and a desktop and documents. But in reality, none of those things exist. They're just a visual metaphor, but allows you to navigate it. That was an enormous breakthrough. And that created the computer revolution as we knew it, starting in the mid 80s. Same thing with the internet. The original internet, the browsers were text and images opening up in different windows. And Mark Andreessen from Andreessen Horowitz, famous venture capitalist, created the first browser called Mosaic by combining the text and images onto a single window. And then they wouldn't let him license the code, so he went and created Netscape. So again, what made the internet take off was creating a user interface that non-technical people could use. And you saw the same thing happen with the iPhone. The original mobile phone was the BlackBerry, only text. And what Steve Jobs did was he realized, so it's touch screen plus a graphical user interface was the iPhone breakthrough. And actually the computer was a graphical user interface plus a mouse, right? So it was that combination of how the user wants to interact with something very technical. You have to understand, you have to map essentially what the technology is to how people think. You have to map it to their five senses. And then you have to map it to the job to be done. So that's why this bridging or mapping from hardware, from technology to people, that's actually like what is happening inside the tech industry. That's what the platform industry does to hardware and what the applications are doing to platform.
Yep. Yeah, that makes sense. And the thing I'm trying to work out as you were explaining that, Ben, is how does this now apply to the more recent waves of technological innovation? How might there be a bridging between some of the early technology that we've seen in terms of AI, at the very least, these kind of chatbots and whatnot, and then the applicability for users? Because some of us, by the way, are already using these things, early adopters and so forth. The technology itself seems so incredible, so powerful, but I don't actually think that we're really past the earliest innings of this.
We're definitely in the early innings, and it's why it's so applicable. Because if you understand the pattern or you understand the map of how things play out, you can understand where we are, what's coming next, and then how to invest or how to entrepreneur. As I said, if you look at like the computer, the initial screen was DOS, text, internet was text, BlackBerry text. AI's first use case is a text chatbot. It's just text. And the interesting thing is the LLMs, the large language models that drive the chatbot, ChatGPT, have been around for years. And the innovation, the unlock, and actually surprised OpenAI was the chat interface on top of the LLM. So that was the interface breakthrough. But we're still in the text period. And as we said, it goes from text to images. And so I'll give you an example of mobile. Mobile starts out text, like Twitter. It as advances, it goes to images and text, which is Instagram and Pinterest. And then it advances some more and it gets to TikTok. And so the reason why it advances that way is that in the beginning of the new platform and the new hardware is it doesn't have enough compute to do something really intense. And so text is low compute. Images require more processing because there's more data. And videos obviously require the most amount of data because there's just way more data, obviously, in a video than an image, than a text. For example, internet started with GeoCities. GeoCities was the third biggest internet company in 1998. Then images plus text is like eBay. And then video internet is YouTube. And each one starts after the other, and each one gets to popular explosion when speed, cost, quality all come together. And so with AI, we're not actually at that point, but it's definitely coming because of Moore's law and Wong's law, which we can talk about later. So what's happening behind the scenes and why you haven't seen applications and why you're sort of still wondering, is this AI thing going to amount to anything, is people have to bridge this by doing this exercise of trying to map what the technology can do to how a person wants to use it. And so what happens is that in the beginning, software developers, software engineers are doing that with hardware, and they're creating this platform. And that's what OpenAI did. And that's the initial customer of all technology are software technologists, are other technologists. And that's where we are mostly today with OpenAI. We have a OpenAI access to their API, and we're trying to build an app, and other people are building apps. But that pattern is just repetitive. And so seeing this sort of snapshot and also knowing there's this lag, I didn't mention the lag on average from platform to application is 36 to 48 months. So iPhone's 07, Uber 2011, 4 years.
So large language models, at least when everybody first started getting to use them all at once, roughly coming on 18 months to 2 years now?
November
right?
2020.
It's actually been
November 22, I think would you say when it all launched. And so 36 to 48 months would be 2025, 2026.
right. Okay. All right. We'll see what happens. Clock's ticking and it gets more and more exciting. Shall we move on to democratization?
Yeah, due to democratization, I mean, it's some of these people in the tech industry, they're so familiar with it, democratization and bundle, unbundle. I'll mention sort of one interesting thing about is, again, a little bit technical, but I found it uncanny. So programming languages also follow this bridging pattern. So in the beginning, when you had invention of hardware, invention of computer, everything was zeros and ones. So the original software language was in zeros and ones called binary code, machine code. And then somebody invented an abstraction that's a little bit more human friendly called assembly code. It's like hexadecimal. But anyways, it's I barely got my arms around it. My CTO was giving me a tutorial over the weekend. And then the third generation that came after that in the 70s was what now is how everybody software programs, Java, JavaScript, C++. And the reason why it's so relevant to AI, I'll tell you in a minute. But each new generation of languages are more human friendly, more abstract. And the fifth generation, which is speculative, might be AI.
One of the promises of AI is that people who never learned how to code can still take advantage of these languages, right?
Yeah.
Because, for example, like if I work a lot with statistics and economics and whatnot, but I never learned how to code, I never learned R or Stata or whatever, okay, that means there's a lot of things I can't do in terms of charting trends and analyzing trends. But if I can just go to an AI and say, hey, I want a chart of the following, and then just say in plain language, in English, in other words, what I want, then the AI can just write the code for me and spit out the chart. I'm actually quite looking forward to that day. I think it's coming quickly, too, by the way.
Right. And that is a perfect example of democratization. And so you're democratizing the ability to code by
Even to dummies like me, absolutely.
both of
Yeah.
us, right? Where you get to an abstraction that's high enough that you become less and less technical, and it makes it more and more accessible to more people. And the idea that either one of us could say, okay, let's code up an app that does something really nerdy that we would be excited about. That's something that was impossible for me without learning like one of the third generation. I skipped fourth generation, by the way, just to let me mention them. R is one that you just mentioned. SQL is another one. And SQL is the most commonly used programming language in the world. The data analyst can use SQL, but if you want to do software programming, you got to actually be at the third generation. So each generation requires less technical background. And so that's a really good illustration of this sort of democratization. And so another one is just looking at just broadly Moore's law over the last 30, 40 years. Gordon Moore was one of the founders of Intel, and he noticed this trend in the manufacturing of chips, of semiconductor chips, that every 2 years they doubled their computing power. You could actually have twice as much compute for half the price every 2 years. And so in 1968, 69, there were about 1,000 transistors on a chip. And by 2023, there were 50 billion. That's how you have 100,000 times the power in your iPhone to the space shuttle computer, is that the Moore's law increased the power exponentially, drove down the cost, increased the speed, and then also decreased the size. And that's a form of democratization of power, because essentially if anybody can get it and it's really cheap and it's really powerful, then more people can do stuff with it. You were talking about wanting to do some cool economic analysis. So in 1980, you would have had to go to a Cray supercomputer. Cray computers were like the state of the art for computing. That computer back then cost $40 million, which today, if you took an iPhone and said, okay, if I could buy an iPhone in 1980 with the same power, it would have cost 200 billion.
Yeah.
So how much does an iPhone cost? Like $300, $400, $500. So something that would have cost 200 billion, it would have been impossible. But if you look back at the amount of computing power, how much it cost in 1980 versus now, talking about a reduction in cost of $200 billion, is absolutely insane. And one other fun fact I found is that Cray computer weighed 5.5 tons. So it took 30 people to assemble it. And you're talking about having something, I think, 50 million times more powerful in your hand.
Yeah.
That's behind all of this change. And that's essentially a democratization. As more computing power becomes available, things that were only possible for somebody who is either very technical or big corporations can now be done by individuals who are less technical. And that pattern means that you open up new markets and open up new business applications that weren't possible before.
Yeah, absolutely. Worth noting, by the way, that Moore himself said that at some point, Moore's law was likely to stop holding, that at some point it might break down. And yet it lasted for an astonishingly long period of time. I have no idea if it continues to apply now, but it's remarkable that kind of exponential growth kept going for as long as it did. And for all I know, might still be going on. I just don't know.
Yeah. What's funny about that? So people have been lamenting the death of Moore's law for a long time. They said it's going to come to an end, because at the beginning of the last decade, or about 2012, chip was about 28 nanometers wide. And now it got, or not now, about last year, got to about 5 nanometers wide. And so people were seeing that at some point it can only be so wide before it can't be any thinner. Otherwise, quantum physics of it disrupt the ability to work. And the irony is, and this I always see is once when like mainstream people declare something over is when it actually gets rebirthed. So have you heard of Wong's law?
No. What is that?
Yeah. So Jensen Huang is the CEO of NVIDIA.
NVIDIA, yep.
And in 2018, he went out and he made this speech and he's talked about supercharging Moore's law. And then people just started calling it Wong's law after him. So this is why NVIDIA is worth so much money. So over the last decade, Moore's law, if it doubles every year, is equivalent to 32 times more compute power over 10 years. So NVIDIA, which took a different approach, they don't just look at the packing basically like transistors on a chip. They also look at the networking and the algorithms and the architecture, look at everything. They take like a holistic approach is how they sort of describe it. They have been able to increase compute by 1,000 times in the last decade.
In other words, they blew Moore's law out of the water.
400 times more.
Yeah.
And that is something that's been going on since about 2012. Most people didn't know about it. And that's also why people in AI are so excited because they see it's not 2 years from now, everything's going to be twice as computationally powerful. You're talking about like 10, 20x. And so it's the rate of improvement is actually vastly accelerated. And I can put some charts up or something, but it's why being optimistic about AI actually makes a lot of sense. The underlying hardware changes are extraordinary.
Excellent. Shall we move on to pattern number 4, centralization, decentralization? Go even deeper on that one?
Yeah. This one, again, is like most tech people think of it as a monetization strategy. And so it's actually from a famous quote by Jim Barksdale, who was the CEO of Netscape. He said something like, "Gentlemen, there are only 2 ways I know how to make money, bundling and unbundling." There's an economic way to think about this, but there's also a technological way. And obviously, the mainframe was a centralized technology and PCs were decentralized. And the internet actually was even more decentralized than the PC. And actually, what happens is a lot of times when things get highly centralized, they usually get ripe for decentralized or becoming distributed. And when sometimes things get overly decentralized, they get ripe for centralization. So cloud started re-centralizing. But let me give you some examples of famous ones. So it used to be that if you wanted to do any graphic rendering, if you're going to make a video game, or maybe if you're an artist, you needed to buy a workstation. And the most famous was Silicon Graphics workstations. And this little startup said, hey, what about if we just created like a graphics card you could put in your PC instead of having to buy a whole workstation? And those graphics cards were called GPUs, which was NVIDIA's invention. And so they unbundled the ability to do graphics rendering from a whole workstation, right? It's like a deconstruction. IBM, which is the famous like centralized player, used to have everything we think of in tech used to be just IBM. They were the hardware, they were the software, they were the application, they were everything. And so networking technology that allowed computers to talk to each other was all integrated into IBM. And then it got deconstructed by Cisco and Juniper, and they created this massive new market, right? Which is like a deconstruction of existing players. So if you think about the present, you look at who seems very centralized and likely to get deconstructed, it's Google and maybe Apple. Google probably ends up having a successful AI application, but their dominance of internet seems ripe for deconstruction. And you can look back and see like Microsoft famously missed mobile. And so if you miss one of these waves, it creates this enormous risk that you actually get disrupted and go out of business.
Although interestingly, in the case of Microsoft, they very much caught one of the next waves, which was cloud, and they've done incredibly well because of it.
Yeah. Same with Apple. So Apple missed the internet. And then Steve Jobs showed up and invented mobile or reinvented mobile. One of the things it's in a later pattern, is that one of the big tech incumbents is actually can miss one wave, but they can't miss two. If they miss two, they're gone.
Yeah, one interesting example on unbundling, bundling is actually from my former profession of journalism. As people know, newspapers have not been doing great financially for the last few decades, frankly. There are still some big national newspapers like the New York Times and the Wall Street Journal that have a lot of different things contained within them. But most newspapers, especially at the local level, the ones that still exist, they're a lot smaller than they used to be. And part of what happened is that your newspaper used to have everything. It had obviously the news, but it also would have sports and it would have crossword puzzles. And crucially, it also had advertisements in there as well. The internet comes along. What happens? You have unbundling. You have now online sites that can be very niche. So you might get your sports on the internet instead of in the newspaper, niche news sites as well. Advertising crucially went to places like, I don't know, Google or Craigslist or whatever. And so the business model was totally gone. But more recently, people have noticed that it went too far, the unbundling, because people started thinking, if I have a website, I don't need a homepage anymore for a news site. Why? Because everybody goes to find their news in these social media places. They go via Facebook or they go via Twitter or what have you. And people realize that actually some readers of the news like things to be consolidated in one place, at least organized a little bit. So now homepages are making a comeback. That's a very small example, but it's one instance where you can see that in some ways, unbundling, if it goes too far, contains within it the seeds of its own reversal, and then you get more bundling. And then when bundling goes too far, it creates within itself the potential for some unbundling later. So it really can move in this kind of cyclical way.
Yeah, you can feel it today because most people feel overwhelmed by information because everything's unbundled. Where in the old days, you only got your news from CBS, NBC, ABC. It was entirely bundled. Let me do pattern 5 because that's the one that's really new information. I didn't see it anywhere out there. And that's the financial patterns in all of this research we did. So I mentioned that each wave was 3 times bigger than the last. So we took what we thought was the maturity of each point of the wave, because as we said, a wave start with it. There's a breakthrough, adoption curve, maturity, and then it declines. Senescence. It just, no one uses mainframes anymore. And the PC industry in 1995 was worth about $186 billion. And then the internet peaks a decade plus later and peaks about $650 billion, about 3 times bigger. And then mobile is 2 trillion, cloud is about 5 trillion, and AI we think is then 15 trillion. And that's actually on average a 17% CAGR or 17% annual growth rate. Was pretty consistent. And the reason why it's been pretty consistent is that underneath of it, the underlying motor is Moore's law. That's, I think, the reason why it's so consistent. And it's actually funny because there's this famous story in the venture world. This guy, Mike Moritz, who was the CEO of Sequoia or whatever, lead managing partner, he took it over from the founder, Don Valentine. And when he took it over in the early 2000s, he looked at Don Valentine's success. Don Valentine had done Cisco, Oracle, and Apple, which were up till then the greatest returns in history. And he said, how am I going to match this? This is insane. And then he made this intuitive leap that he said, as Moore's law continues, then the markets that technology can address actually get bigger because Moore's law is just more exponentially cheaper and better. And so to see the math match his intuitive leap, that it actually, cloud was 3 times bigger than mobile was 3 times bigger than internet, is like uncanny. And then a couple other interesting financial patterns that we saw is that the market share split between hardware, platform, and applications was actually fairly consistent per wave. So just an example. So in mobile, the hardware gets about 25% of the economic value. The platform gets about 25%, And the applications like Uber and Airbnb, those are applications, those have got about 50% of the market cap. So you see this sort of 25, 25, 50 split. That's an interesting pattern. This is very much a financial pattern, but it's a winner take all business. This is why you said the winners and losers are so important. And so it's unbelievable how much the top two companies take of economic value. So in the platform level, so the platform is like an Apple or a Google, they take 80 to 90% of all the economic value of the platform, right? It's super, super, super consolidated. And that's been consistent going back to the PC, right? Microsoft and Apple were 80% of all the market value. And you go to like hardware, same thing, super consolidated. It's usually about 50% of the market value is in the top two players. So you see this very consistent hyper consolidation or winner take all dynamic across every platform, which is why the VCs are so obsessed with trying to pick the winners.
I'm intrigued by the idea that there eventually is this stable ratio that emerges of 25%, 25%, and then that last bit, 50% for the applications. But of course, I'm imagining that as a new technological wave sort of evolves, that ratio itself is also fluid. Because at the beginning, I imagine that quite a bit of the value is in the hardware because that is what exists and that is the thing drawing in all the enthusiasm. And then that later over time, you end up with all these new applications that end up taking more of the value because people start seeing the value to them and then it grows.
That for sure. I was just looking at the mature wave and how the economics are broken down. So on a typical mature wave, there's only 5 or 6 hardware companies that have 95% of the economic value. In the platform, there's only 3 or 4. And in the applications, there's only 15 to 20. So you're talking about at most 30 companies representing 80, 90% of trillions. So in AI, if it's 15 trillion, you're talking about a very small number of companies being very valuable.
Worth an outrageous amount of money. Yeah.
Yes. That's why venture industry exists.
Yep.
And I think that a lot of the popular desire is to see big tech companies go down, or at least to be reduced in power. But what's interesting is that the waves typically add new major big tech players. And so you get more competition, not by reducing power, but by adding new players. I called it the +1, -1 pattern because if you go look, you had mainframe, you added Microsoft and Apple. Internet, you added Google and Facebook. Mobile, you added Apple and Instagram, which actually was Facebook. Cloud, you added AWS. Amazon wasn't really a technology company. And now AI, you're adding OpenAI. So I actually think that one of the lessons is that the key is, in order to get more competition among big tech, is to encourage the addition of new players in these major breakthrough waves and make sure that the regulatory environment is conducive to that kind of competitive dynamic. And then look to some losers. And the funny thing about these losers is that you actually probably never heard of them. People who were the major players in these waves up until recently all know this stuff because they were around. The inventor or the dominant player in word processing was this company called Wang, started by this guy, On Wang. It had 33,000 employees and $3 billion in revenue in 1980, right? So this is a huge company. And when the PC showed up, he famously had a quote saying he's not going to disappear in a year. And he disappeared in 2. DEC, Digital Equipment Corporation, which is a company that had 130,000 employees.
Huge, yeah.
Yeah, gone. These disruptive waves are very consequential, and people in the industry, a lot of them worked at these places, like John Chambers, who's CEO of Cisco, was vice president of Wang Laboratories. And a lot of people who worked at Sun Microsystems, which ended up not being able to transition. They were also a server company. ended up going on to run a lot of these other big companies. So these waves, everybody who's in leadership at tech has lived the highs and lows of these waves. The near-death experiences of Apple and Microsoft, because Microsoft hadn't caught cloud, they would be gone.
Yeah, it's fascinating to think of some of these counterfactuals. The other thing that's curious about all these companies too is that we are right now mainly talking about companies in the information space and the seemingly unrelenting, ongoing digitization of the world, right? But these companies occasionally do get involved in other kinds of technology as well. Apple made a move into EVs. Looks like that may not happen. From the outside, for example, Elon Musk, Tesla are involved in artificial intelligence. And so there is some overlap with other kinds of technology. And I don't know, maybe as a follow up project, it'd be interesting to know if some of these patterns, some of these trends also apply to things like clean energy, to new transportation, to things like biotech, all these mRNA vaccines and whatnot. I have no idea what the answer to that is. And I understand why we're focusing on these particular kinds of technologies because it seems like one has logically followed from the last. It'd be interesting to know if this also applies to other technologies that maybe apply more to and stay within the more physical realm of atoms as opposed to bits, as I think a lot of tech people refer to it.
Okay, you don't know this, but I am planning on doing one on military technology.
I know it now.
And I have
great.
I have a professor I've lined up. I've done a lot of thought and reading on this over the last couple of decades. That one I know for sure it's applicable. I'm loosely confident based on what I know that it's true for clean energy. I think one way to bookend this or capstone is the big consequences. So Mark Andreessen famously said, software is eating the world. And so I thought I'd put some numbers against that. Some of these everybody knows. So let me do the one that most people know, and I'll do the one sort of not as many people know. So e-commerce was 1% of all commerce in the year 2000 and is now 16% of all commerce. So it's slowly been eating up commerce to the deep dismay of the retail industry and people who own retail buildings like malls. So here's an interesting stat that I feel like I hadn't seen before. So how many employees work in retail trade? So according to the BLS, 15.6 million. So 16% of 15.6 million is 2.5 million people. So e-commerce should employ 2.5 million people because it's 16% of all commerce. How many people does it actually employ? 500,000.
Oh, man. Yeah.
Yes. So software, it's a good example of software driving a change in work patterns, more efficient productivity, however you want to describe
Productivity
it.
growth. Yeah, absolutely.
So here we give you another one that
technology.
that
Yeah,
I
please.
think is interesting, less well known. How much do S&P 500, so companies, spend on software a year? So in 2016, they spent 3% of all their revenue on software. And in 2024, or 2023, they spent about 6%.
That's a big move, actually, to double the share of your revenues
In
that
8
you end
years.
up spending on software. Yeah, absolutely.
So if that slope continues, it should be about 10, 11% by the end of the decade. 10, 11% of all corporate spend spent on software, which doesn't sound that much until I tell you how much is spent on labor.
Okay. Yeah.
So the S&P 500 spends 10 to 11% on SG&A, on people. So it'd
be a perfect match if that earlier trend actually continues. By the end of the decade, we'll be spending the same amount on software as on labor.
Labor. And it's possible it's accelerating with AI and with Wong's Law.
Yeah. Worth noting, by the way, that might sound scarier to people than it should, because, of course, this would also imply that the economy itself will benefit from these productivity gains. And so it doesn't mean that jobs will be permanent lost, that there will be permanent net job loss. It means that everybody will be way richer and that wages will be higher, and that in fact, there still will be people getting hired. That's not a guarantee, okay? But so far, if you look at history, that is how it has played out with some very big intermediate disruption. So I'm not guaranteeing anything. I want to be absolutely clear. I'm not guaranteeing anything. It's hard to predict these things, but I'm saying we don't need to necessarily be frightened by the fact that companies are spending more on software. It also could just mean that they're going to make the people who do work for them more productive, which means faster real wage growth. Yay, you can afford more things, have a better living standard, et cetera. Or yes, it could mean that a lot of people do lose their jobs and that there's a period of disruption in between. And that's terrible. But we don't know is the point. Like that statistic by itself is not dispositive of anything else. I just want to make that point.
Yeah, I have one more stat that is consistent with what you just said. No, it's a positive, consistent narrative. Over the last 30 years, it used to take 8 employees to produce $1 million in revenue, and now it takes 2. So it takes 2 employees to make $1 million in revenue for the S&P 500 on average. So that means that revenue per employee, 4 times more revenue per employee. What was the SG&A or percentage of revenue spent on labor over the last 13 years?
I know.
Yeah, is it declining? Is it increasing? Or is it flat? You have revenue gains per employee, but do you have less employees as a percentage of revenue?
I don't know.
So no. It's been flat at 10 to 11% for the last decade and a half.
So it's a relatively stable trend. By the way, that's across some very divergent business cycles as well.
And across a lot of different kinds of businesses. So is exactly what you said, which is even though companies are getting more productive, more revenue per employee, they're maintaining on average the same amount of employment as a percentage of revenue, which actually means more employment and more wages because revenue is going up.
Yeah. By the way, a simple way to think about this is that in the last, I think, 8 years, you said that share of spending on software has doubled, and yet unemployment right this very second remains below 4%.
Software
labor market's healthy.
In other words, software spend doubled and employment spend didn't change.
Got better, actually.
Like wages went up because you had better productivity. So anyways, the consequences of the technological gains have been wealth and prosperity. And so I think with everything we just said, the pattern is telling us that we're likely to go into a very big economic boom, a technological boom. And as you said, there might be short-term disruption, but the consistent pattern of mainframe to PC to internet to mobile to cloud have been very beneficial for society. And the United States has been leading all of these technologies now for decades. So another optimistic note coming from me.
I love it. I love it. And probably a good place to wrap up. Hey, Ben, on the 3X multiple, you weren't thinking of naming that Miller's Law instead? Have your own law, man.
No.
Not yet? You don't want to make that bold a proclamation just yet to say it's a law?
Yeah. The challenge is that Moore's Law, we just broke Moore's Law, but AI is going at 10 times faster. And so it's a question of, are we actually going to see much higher productivity growth, much higher market values than what we see in the past? Because the challenge with extrapolation is you're extrapolating the past into the future. And if the future is not like the past, it's not a good trend. And so I actually think we are likely to see, if you said 10x the past, because you have 10x the computational power, the rate of change is 10 times faster. That's 150 trillion.
What a future that would be. Entrepreneur by day, crime-fighting podcaster by night, I think. Ben, always a pleasure, man.
Yeah, thanks. It was awesome, Cardiff.
You've been listening to Onward, the Fundrise podcast, featuring Ben Miller, CEO of Fundrise. My name is Cardiff Garcia of the Economic Innovation Group. We invite you to please send your comments and questions to onward@fundrise.com. And if you like what you heard, rate and review us on Apple Podcasts and be sure to follow us wherever you listen to podcasts. Finally, for more information on Fundrise-sponsored investment products, including all relevant legal disclaimers, please check out our show notes. This podcast was produced by The Podcast Consultant. Thanks so much for listening, and we'll see you next episode.